All right. Now we're going to start looking at the actual unit circle. The unit circle is anytime you have a circle with a radius of 1 and the center of the circle is at the origin. So we're going to have a circle. This is going to be your center. It's going to be at the origin. And your radius, the distance from the center to a point on the circle, has a length of 1. So this is going to get you 1 on the x-axis. This is going to get you 1 on the y-axis. It's going to get you -1 on the x-axis and -1 on the y-axis. Okay? So the unit circle, radius of 1, center at the point 0, 0. Okay? And what we're going to do is we're going to be looking for points on the unit circle. Okay? So we're going to be looking for the coordinates of points on the unit circle. When we throw the angle that we were sketching on the other side of the notes, we're going to put that angle on the unit circle. So again, we're going to have our vertex of our angle at the center. This is going to be your initial side, and then your terminal side will be wherever that happens to stop. Now what we're going to be interested in is what's the coordinates of that point. Where is that point located at on the circle? It obviously has some x and y value. Okay? So we're going to need to calculate out what that x and y value is. Well, what we can do from this point here is we can draw a line straight down to our x-axis. Okay? So I'm going to draw a line straight down to my x-axis, and this actually forms a right triangle. Now you don't have to draw it down to the x-axis. You could actually draw it straight across 90 degrees to your y-axis. Out of habit, I just always go down to my x-axis. Okay? So on here, we know the coordinates of this point could actually be found using this right triangle. If we went across to here, this would be your x value. That's the x value of this point, because it's how much do we need to move over, okay? And then how much do we need to move up. So this side of the right triangle would be your y value. Okay? Now on a unit circle, we know that the radius of this unit circle is 1, okay? Which makes any radius around the circle equal to 1. So the distance from here to here is going to be equal to 1. Now you probably recall on the previous side of the notes, I said that our right triangles are always going to have hypotenuses of 1. And they're still going to be that way. Okay? Through the whole unit, hypotenuse of our triangles is going to be 1. It's going to represent the radius of the unit circle. Okay? So let's take this triangle off here. We know this side is x, and we know this side is going to be, y. And now let's figure out what x and y are actually equal to. Okay? Now, what we're going to know is we're going to know what this angle measurement is. Maybe this is, maybe it's 30 degrees or 60 degrees, whatever the angle measurement is. So again, theta here, theta just represents the angle measurement. And theta is a Greek letter, represents an angle. Okay, so theta represents an angle. And now let's use SOHCAHTOA. You know, SOHCAHTOA. Okay, let's use SOHCAHTOA to find out what these sides are equal to. Okay? So let's find x first. Here's our angle measurement. Here's our 90-degree angle. So we know this is the hypotenuse. So where is x compared to our angle? Well, this is the adjacent side. Okay? And we know this is the hypotenuse. So these are the two sides I'm going to use so far. I'm going to use the one that I know and the x that I'm looking for. So this is hypotenuse, this is adjacent. So adjacent and hypotenuse is cosine. So let's write this. Cosine of your angle, which is theta, equals adjacent, which is x, over your hypotenuse, which is 1. Okay. So this actually means that x, because x over 1 is just x equals whatever the cosine of theta is. And our calculator is actually going to give us those, values. So the cosine of theta is equal to x. So cosine of theta is your x value. So this x value of that point is represented by your cosine. Okay. Now the y value, where's y compared to theta? That looks like it's opposite. And 1 is still the hypotenuse, so that's your sine. So the sine of theta equals opposite, which is y, over your hypotenuse, which is 1. So that makes y over 1 just equal to y, so y equals the sine of theta. So your y value of this point is represented by the sine of theta. So if you want to find the coordinates of this point, the x value is the cosine, and the y value is the sine. Okay? So if you want to find approximate values, you can plug those right in the calculator and get your approximate values. Now, if you want to get exact values, you're going to use special right triangles, the 30, 60, 90, the 45, 45, 90, which is what we're going to do in the next section in the next video.